Так, будь ласка.
Мене звуть Герман Олег. У мене задача стоїть в тому, щоб спрогнозувати показники, температурні показники у місті Києві. Я застосовував дані про максимальні температурні показники в Києві з 1 лютого 1951 року до 10 лютого. І там наступні майбутні показники я мав якось орієнтуватися на, які вже були по факту, щоб перевірити достовірність даних, певно. Добре. Зараз покажу вам початкові показники. Це, якщо бачите, це мій код, але саме цікаве це ось це. Це мої початкові показники. Це я так вивів їх у такому вигляді, щоб якось візуально було видно, що є певна сезонність, тобто, очевидно, що влітку тепло, а взимку холодно. І тут усі показники. Третій стовпчик можна трошки проігнорити, тому що він був у мене для отримання певних даних щоб в програмі можна було додати їх. Тому ось. Ось видно, що є там з 1 лютого, і усі дані є на кожен день. І вивів у такому вигляді графік. І тому я протестував загалом усі ці дані на 4 різних методах прогнозування. Перший метод це був найпростіший, який, ледве майже не найперший. Це метод звичайного експоненційного згладжування. Зараз трошки зміню масштаб. Ось, тут знову усі є показники з 81-го року. Нас цікавлять лише результати і, як виглядає сам графік. Як я вказував у своєму звіті, думаю, там більше все буде описано. Якщо метод експоненційного згладження, то видно, що він так дійсно чудово повторює вхідні дані, зглажуваний ряд цей. Але, на жаль, він дає доволі хибні показники, і в нього дуже лінійно йде наступні показання, як тут видно. Тому я став, грубо кажучи, модифікований метод цього експоненційного згладження, він метод Хольта. Основне ключові зміни ще також в цьому методі, в тому, що я використовував показники якщо поляш, 11 лютого за кожен рік з 2021 по 2021. По 20 і 21 був прогнозований, і я ще на найпростіший випадок на 22 прогнозував. Також видні результати, бачимо цей графік, і у звіті я також сказав, що перше за все це нелінійне передбачення, тому що, якщо видно, то дійсно є варіативність, не лінійно, просто якщо далі прогнозувати, то він дає нелінійні показники. Із мінусів я хотів би сказати, що дуже погано він повторював цю криву даних, і я вважаю, що це можливо показники певної хибності, але в середньому якось показники около того, якось вони дійсно схожі на те, але точність знову не висока. Другий показник – це метод Вінтерса. Другий метод – це Вінтерса. Унікальність його полягає в тому, що він використовував певні сезонні показники, до яких майбутні показники звертаються аж навіть рік тому. Як видно, також він дуже чудово повторює попередні показники. І також є нелінійність прогнозування, але все ж таки доволі низька точність, якщо бачите в мене в звіті. Так, чудово повторює вхідні дані, нелінійне, тому що видно, що також, тому що він звертається до сезонних показників інших років. І Ну, але точність знову недостатньо висока. І тепер зараз покажу метод на нейронних мережах. Вибачте, заздалегідь не запустив її. Так, ну, перш все можна, поки запускається, мережа може встатися на загальний код. Ну, це взагалі цей код, він спочатку просто збирає цей елемент, збирає всі дані і через зараз через скрипти. В цих скриптах він оброблює ці дані, у цьому моделює дані, і знову в початковому коді він виводить цей графік. Поки запускаються графіки, я можу вам писати у звіті його. Видно, що так, я, як раніше казав, були великі викиди, я трошки це пофіксив, але все ще виникає ось один такий викид, і мені це не сильно подобається. Це я додав до мінусів. І ще один з мінусів цього показника, що він не дає конкретних значень і тільки показує, збільшу трошки для вас, показує прогнозований зріст якогось тренду. Ну, на щастя, ці показники зросту тренду доволі точні протягом усіх, протягом усього періоду часу. Так, і якщо приблизити до останніх наших показників, наприклад, то теж видно, що правильно вказує десь хвилястість, десь спад йде, і взагалі десь спад, потім вказує зростання і так далі. І нас дійсно є ще цей фактор і цікавить. Ну, це от загально, як виглядає моя робота. Ну, якщо, мої останні думки, мої висновки, якщо треба конкретні якісь значення отримати, то я б, якщо касатися такого показника, як погодні показники, то я би обирав метод Вінтерса, тому що, як мінімум, він більш максимально наближений з усіх варіантів показує результати. Але якщо треба дізнатися просто зростання чи спадання, то дійсно метод на нейронних мережах мені більш сподобався. Інші методи, як Хольта чи експоненційного злажування, можна якось застосовувати в інших показниках, які більш передбачувані, які не залежать від багатьох факторів, як ми трохи раніше спілкувалися. Дійсно, погодні показники – це не тільки лише чисті числа, які треба робити, а ще і якісь там, це, грубо кажучи, залежність різних показників факторів, і такий ось результат виходить.
Добре, а джерело даних можете відкрити, де звідки ви брали дані?
Якщо знайду. Перш за все, багато, якщо із останніх даних, це, звичайно, там якісь синоптики і тому інше, але якщо знайду, я знайшов ресурс, де можна навіть за ще пізніші дати отримати показники. Я зараз спробую знайти. Ось. National Center of... Так, це їх головний сайт, мені треба їх додатковий сайт. Ну, це у них їх головний сайт, але мені потрібен їх підрозділ, грубо кажучи. Ось цей підрозділ. National Center for Environmental Information. В ньому можна отримати, як тут видно, як запит на показники з Києва з 90-го по 21 рік. І він мені видав усі показники. На жаль, там через те, що деякі старі дані, проблема в тому, що з цих старих даних просто є один показник максимальної температури. Більш новіших, так, там і середня, і мінімальна температура за день, але Але якщо щоб отримати взагалі якесь уявлення, тут дійсно можна за будь-який рік. Також в мене був сайт, не впевнений, що знайду. Він ще на початку 90-х був запущений, просто архів звітів з країн Радянського Союзу, але там теж певні провали є даних. Не впевнений, що знайду ще зараз.
Поки ви шукаєте, я правильно розумію, що дані комбінували з різних джерел?
Я лише, як і зробив, з 80-х по 90-х використовував так, з джерела того які архіви з Радянського Союзу країн, а інші з 90-го і далі я з цього сайту брав, тому що я чогось. Ну, я просто звіряв з іншими показниками такі самі ресурси, як синоптик, то вони дійсно, ну, як мінімум останні 10 років, там на цих ресурсах вони однакові абсолютно. Тому так, це можливо може бути і певною проблемою. Ось я знайшов сайт. Ось, наприклад, цей сайт. Просто звіти за кожен рік та місяць, навіть до 80-го років за Київ, тому доволі також я використовував ці дані також певним чином.
Добре, тобто це не основне джерело все-таки?
Це було не основне було ось цей сайт. Я просто, ну, грубо кажучи, ці пробіли і з цього брав ресурсу.
Зрозуміло. Все, що хотіли, розказали, так?
Так.
Добре, тоді дякую.
Дякую.
Good morning. My name is Karina Karavai, and I choose COVID-19 vaccination progress topic. I think it's quite topical nowadays because everyone is interested in the progress of vaccination, the disease spreading, and so on. So I'd like to start with dataset description. Okay. Can you see my screen now?
Yes, of course, sure.
Okay, thank you. So as I said before, I choose COVID-19 vaccination progress dataset, and I combined it with COVID-19 data repository that provided by Johns Hopkins University. This is a dataset on the basis of which most tracking system exists, and also I added information about population, and moreover created a little custom data table with vaccine information. I'd like to show these tables. Here we have, for example, vaccination progress initial table. For each country, for each date, we have a total vaccination number, daily vaccination, and so on. We also have the vaccines that are used in this country, the source name also. Then I add the population data table, and this is mainly for increase the quality of number of indicators like percentages of vaccinated people. And also I collected data about different vaccines from the open sources and news, and created a little tiny additional table with vaccines for each vaccine. I found information about its cost for Ukraine, its efficiency, type, and needed doses for in order to vaccinate people completely. Also, the additional table which is common data set for tracking COVID-19 disease spreading, and it contains data about confirmed cases, number of deaths per day, and also number of recoveries. All this data are gathered since January last year, and nowadays there are literally thousands of rows in this table, so they are big enough. And in general, my data representation star scheme, I'd like to show it right now. It's actually consists of I didn't open it. Let me, oops, I'm sorry. I didn't, if you, I'm gonna stop a share for a few seconds and open star scheme because I forgot to open it right now. So, okay, and I'm sorry, I just rebooted my laptop and okay. Oh,
Okay.
I open my report right now. Can you see a PDF file with star scheme or
No,
no?
just a PDF file with report
Okay.
with the map. Yeah,
And
and
right now?
now star scheme.
Okay, so it basically like consists of two different stars. The first one is for COVID data repository, where all relations are 1-to-1 actually with key pair country date. So in each table, there are key pair country and dates, and based on this pair, we can map this as 1-to-1 relation. And the second star is about COVID vaccination progress dataset with 1-to-1 relation in these two tables, vaccination and population tables based on countries, and one-to-many relation based on vaccination and vaccines tables, since for each country can be few different vaccines, can be used two different vaccines. Okay, and now I'm going back to
Now, now we can see your Jupyter notebook.
That's not what I wanted. Okay, share. Okay.
And now
can
again,
you
star scheme.
see?
Yeah, and now graphs. Chart.
Google Data Studio.
Yes,
Should
Google
be
Data
on
Studio.
the screen.
Yes.
Yes. So I created 4 different dashboards. The first one concerns vaccination progress itself, and it was built based on vaccination progress and population tables. Here we have main KPI. Here is the percent of vaccinated people in the world. At the moment, the value of the indicator is not very good. We're in red zone right now, right here, and as we can see, we are far away from the green zone. So we have to speed up vaccination progress in order to improve this KPI. There are also 2 tiny spark lines for visual representation of the growth in number of vaccinated people in the world and the average value of vaccination per day. Nowadays, we have about 80 millions of vaccinated people in the world, and about 50 daily vaccination 50 vaccination per day. And as far as I know, the governments of different countries plan to improve this, to increase this value up to 1 million per day. Also, on this dashboard, we can see a bubble map, and the bubble size represents the percent of vaccinated people in each country, and the bubble color corresponds to different vaccines or their combination that are used in different countries. And also the tiny pivot table with the percent of people vaccinated and fully vaccinated in each country, number of people vaccinated and fully vaccinated in each country, and also daily mean. As we can see, the most vaccinated country, if we talk about percentage, is Israel, Gibraltar, United Arab Emirates, and so on. But the most the greatest number of vaccinated people is in the USA, and it's because of the different sizes of population, actually, because the population of these countries are not so big like as in the USA. Also, there's a line chart and it shows the number of vaccination for each country for every day. Here we have, and as we can see, United States are in the top of this chart, and also China. There's a little problem with China data because they provided this data with a specific period, like few weeks, and as we can see, its chart is like it's look like a steps. So the next dashboard is about vaccines itself, and here are two KPI: is vaccine efficiency and vaccine dose cost. It is, as we can see, the most efficient vaccine right now with 95% of efficiency is Moderna and Pfizer, and these two vaccines are actually one of the most common vaccines that are used nowadays. And we consider this efficiency to be as high as possible. So hopefully that our scientists are going to continue the researches and improve the vaccines, and also the cost, we expect them to be the lowest possible value, and nowadays the current minimum value for cost is $10, and this is the price for one dose of Russian Sputnik vaccine. And nowadays, most expensive vaccine is Sinopharm. And as far as I know, our government plans to use this vaccine in Ukraine, which is quite interesting to use one of the most expensive vaccines in Ukraine. Also, there's an additional pivot table, histogram, and pie chart. This pie chart displays how common each vaccine is. And once again, Moderna and Pfizer are most common vaccines nowadays, probably because they demonstrate a good efficiency and most people consider them reliable enough. Also, we created two dashboards. One second. Yes, we created two dashboards that concerns COVID-19 disease spreading. It is based on time series data from John Hopkins data set, and we process this data using pandas in order to convert them to an appropriate form for Google Data Studio. Here's a pivot table with total number of confirmed cases, deaths, and recoveries up to specific date, map that demonstrate the intensity of disease spreading, and here's a slightly sad linear chart because this chart demonstrates the total number of deaths in the world up to specific date. The next dashboard concerns recoveries, so it's a bit more hopeful, and it is actually a good part of this report, since we all can see that this linear chart is the total number of recoveries is growing constantly, especially in different, like in countries with high number of confirmed cases like India. Brazil and USA and Russia. So this is actually one of the best parts of this report, and also in each dashboard we can choose an date range, and for example, we can see the information for a week or more, and this is going to update not only for this dashboard, but for almost for each dashboard I show you, except for vaccines, because they are static information that nowadays don't change. Here we have updated information for this week. So yeah, and also I'm going to show I'm going to show this.
Okay, now we see your Jupyter notebook. Karina, we don't hear you. Microphone. Your microphone is off.
Oh yes, I'm sorry. I turned it off. Yes, that my notebooks. There are two different Jupyter notebooks. First one is about world vaccination progress, and second one is about COVID-19 disease spreading. It's data visualization and predictions. And we are going to start from the vaccination progress notebook. I tried to find out how far no, not like that. I tried to find out how many times we need to vaccinate the our whole world, and to build a prediction for an estimation for the total number of vaccination every day. Here's the data from the initial data set. As we can see, it's looks like can be estimated by linear function, even simple linear regression. So I use a regression model and try to estimate it like this. So probably it would be better to use some polynomial kernel, maybe SVM or something like that. And as we can see, we can predict, like, in 50 days, there are going to be about 18 million vaccinated people. And also another notebook is about disease spreading. Here's all the data I load, and it looks like that. So we have, for each country, we have very big number of columns which corresponds to each date since January 22nd of last year. And so we process this data in order to get kind of time series. And based on this data, we're going to estimate the spreading the cases. So here we have, for example, for confirmed cases for every day. The blue points is our data from the data set. So we can see how many cases, confirmed cases in total we have up to specific days, and the green line is our estimation, and this tiny red line is SVM prediction. Yes, I forget to say that I use SVM for linear regression with polynomial kernel this time, since the data is like cannot be estimated by linear regression, linear function as before. Also, I performed these steps for deaths, number of deaths, and number of recoveries. As we can see, the good part that number of recoveries are greater than number of deaths, and its growing is much more intensively. So, and nowadays, all these graphics are still increasing. All the values are increasing, and we cannot see any downs in these graphics. So I think this pandemic won't end in a few months, in the nearest few months. So yes.
Okay, that's all. Yes.
Yes, actually.
Thank you so much. The question is, do you think that linear regression is good means, good method to
Not
make the
really.
forecast?
Yes, I built this estimation at first, and I thought that it was a good one, but now I review these results, and actually I think that I should try like a kernel, different kernel, not linear, and maybe not linear regressions, because we can see that it's slightly, well, maybe exponential as well as here. So, well, it actually not as bad as it could be, but yes, I totally agree with you that linear function is not the best choice for this estimation.
Okay, thanks. It maybe could be like a sigmoid, something like
yes,
that. Yeah?
yes.
Okay, so you mentioned it because of it, I asked you. And could you please return to back to the dashboard? And I have two questions. Can you show the comparison of the price for different vaccines? And you have to
yes, for
measure
cost for Ukraine and cost for
and cost for Ukraine is really different from.
I'm not sure about how relevant this information, because I tried to find this information on the open sources, on the news sites and so on. So this is my own data that I found. Well, it's actually, as far as I know, it's up to date, but
okay, I see.
Maybe slightly different.
And
yeah.
Yes, please.
Yes, and as I said before, the most interesting in this histogram is that Ukraine is planning to use this vaccine, exactly this, which is most expensive.
The most expensive is the best.
Yes, I've heard a little scandal about this. Some people really don't understand why our government plans to use this vaccine instead of, for example, AstraZeneca, which is much more much cheapest for Ukraine, and also have a good results, or even Moderna. Well,
dramatically cheaper.
Yes.
And could you please revert to the map with bubbles?
Which one?
With bubbles, and could you give us more details, maybe to make a different zoom of this map? Yeah.
This data set is actually not full because there are too many empty spaces, and not for every country we have information about the vaccination progress. But for example, for Ukraine, there were no information. Mostly it's Europe, USA, and some country of Asia and South America. As we can see, most vaccinated countries are actually here is Gibraltar, because it's very small and there are a small amount of people. Israel, United Arab Emirates, which is actually understandable because they started, as far as I know, they started vaccination programs for all residents, not even for
citizens.
Not only for citizens, but also for students from different countries, for workers for different countries, and it was like months ago, so it's quite understandable why the United Arab Emirates have such a good percentage of vaccinated people. But again, it's only 36% maximum of vaccinated people. Yes, and also Seychelles, and the United States. Well, they have more than 22 million of vaccinated people, but if we calculate the percentage of the vaccinated people to population, it's only 7%. So they have a long way to go.
Okay, thank you so much. So
Thank you.
yes, please.
So, hello, my name is Anton Zuyev, and I shall present my work today. So the main dataset of my work is dataset of used cars sold in the United States. So in this screen you can see some data from this dataset. So you can see so people tell in what condition their car is, where they sell this car, what is the manufacturer of this car, etc. So this dataset has around 400,000 of rows. It's very big data set with a lot of data. So basically, that's the main data set I used in this work. The second data set I used in this work is this data set. This is basically the locations of cities in the United States and population of the cities and population density too. The set data set I used is United States regions. So I use this dataset to basically visually represent sales of cars by regions in the United States. So let's start with describing what problems I added. So first problem I added is here. Basically, for each sale of car, I find the closest city to this sale and consider that this sale was in this city. So I use basically Euclidean distance because I consider that sales were close to cities. After this, I also added the simple problem sales count, which allows me to basically calculate how many cars was sold for different metrics I used in charts. Then I added a metric city sales count, which basically calculates amount of sales for some city. And I added metric sales per 1,000 people in city to calculate, to basically represent how many cars bought per 100 people, 1,000 people in city. Because I think it's good metric to represent. This is basically all metrics. And now I can show you the charts. The first chart I have is basically a global chart to represent like global trending, global information about models, manufacturers, etc. So for example, if you want to have statistics on Ford, we can click on Ford here. We see how many Fords was sold in our data set. And we also can see on the map how many Fords was sold in each state, for example. Also, we can play with time and have a little different statistic. And we can watch how many models of Ford were sold, for example. Then we move to another chart. This chart basically represents global trends in car sales. So we may see how many different cars with different transmissions, manufacturers, etc. were sold. If you want, for example, statistic for Ford, we also can click here and see that Ford, for example, has a lot of 8-cylinder drives, but a lot less than others 4-cylinder drives. Then said chart represents basically how many sales was on the map. So we can have a visual representation where our service used more and where our service used less. So for example, you can see that California has a lot of sales, but a big population. And for example, Washington has a lot of sales, but population is comparably small. Also, we can see heat map, and basically we see that sales amounts and the population has a direct correlation. So the more people live in some location, the more sales we have in that location. Then I have some charts on timeline. So my dataset represents data for around like 5 weeks, 5-6 weeks. So in this chart, we may look amount of sales per in divisions of United States and by manufacturers for some given period of time. So basically, the basic representation is weeks, but if we want, we may click on some week and see a representation by day. Then the next chart is basically regions and the divisions average prices to see where cars sold for more money or less. We also may click on some region or division and have basically see how amount of sales on that region and division per week. So and as I remember, we may also and then the next chart is a price and sales count by different different regions, divisions, etc. So we can look on global map. We see so basically the divisions of United States. And bubble size represents basically the average price. So the larger the bubble, the more the average price. For example, if you're interested in data in South Division, we may also click on South Division, and we see that South Division contains of 3 regions. And now we can see that, for example, for this region, average price is higher than for other 2 regions. We can click on this and see states. We also can click on state and see a lot of cities in the state and information on this city. After this, we move to another chart. Basically, this is the same chart, but on this chart, we see how many sales we have per 1,000 of population. Basically, this works exactly the same way as the previous. We may click and see the detailed information. This is wait until this load, please. No, this is not what we want. This is price forecast. So this price forecast uses exponential smoothing, which basically means that we have prediction, and prediction based in all of the previous data, but the closer the previous data to current position, the more impact of this data on this result, basically. So we also may click on some specific model, a specific manufacturer, and see prediction. So yes, basically that's it. And another chart. This chart represents clustering of states. So here, Scott, I wrote it in Python, and this chart basically represents clustering of states depending on population of the state and amount of sales. So, for example, we can see that Vermont is very special state. It has low population but very high amount of sales per 1,000 people. And we can see, for example, California has a very high population. Also, New York, Texas, and Florida has a very high populations too, but medium amount of sales. So this chart basically allows us to understand which states our service are popular in, and which states doesn't really use our service. This basically it for Power BI. I also has another predictive models here. I used Python to write it and JupyterLab. So basically here we can see heat map of sales. So basically the more closer to yellow color, the more sales in this position are. So basically this is the map of United States. We can see here I used the DB-strong clustering. So basically I try to get the regions with higher density of sales. So what basically DB-strong does, DB-strong finds the regions where each point has a given amount of neighbors in some epsilon region around it. So basically, if we have a big gray region here, this means that this region has a big density of sales. And for example, if we have nothing here, this means that sales here happen in big distance, basically. And that's it for this chart. It's interactive, but it's slow. So I'll change parameters a bit, and we wait. And while we wait, I show another predictive model. So for this predictive model, I took some characteristics of sold cars, manufacturer, condition, etc. Yes, we have a technical problems here. So basically these parameters, I used one-hot encoding to encode these parameters as numbers. And then I tried using basically decision tree for regression to predict the price of the car. We see basically correlation between predicted price and real price. This doesn't look very good, but if we look at heat map, we see that really most prices predicted and real are located near the diagonal, which means that prediction is fine. But I decided to write a simple neural network with sequential model and two dense layers. And we can see that predictions basically grouped better around the diagonal. So we can tell that prediction with neural network a little better than with a decision tree. And we can see no chart. I think chart changed a little bit, but it's really slow. So yes, basically you can see the chart changed because this was one single region, and now clustering seems that this is two different regions. Yes. I think that's all.
Okay, thanks. Can you please get back to your dashboard with the map? And as I remember, you showed one dashboard with bubbles, and it gives interesting results when you scale, zoom in and zoom out. Yes.
Oh, wait. It's a little bit slow. So, for example, this one, yes.
I don't remember for sure, but someone with information which becomes different when you scale. Yes, scale up and
it doesn't become different. It's basically a relative bubbles. So if this bubble big, this means that basically this bubble has greater average price 1800 than these two bubbles.
So you pressed one of that, for example, this region, and it goes into details. Yes. So
yes.
And we can go into details further and further.
Yes, two cities basically.
Two cities. Can you now zoom in, please? No, I mean,
Oh, yeah,
like we change
you mean
scale,
cities?
change the scale of the map.
Yes.
Yes, this exactly this.
It doesn't look very good because there
Yes,
is a
yes,
lot of cities. So
exactly. But you can go zoom in and in, like
yes,
to make
yes,
scale more detail.
yes.
And now try to go drill up. Yes, so on the
You
to
mean
the high
this?
level. Yes.
This?
And now please zoom out. I see. Okay, good, interesting. And as I understand, it goes in line with hierarchy defined by you. Region.
Yes, hierarchy defined by the stable US regions.
Okay, good. So thank you.
That's all.
Okay, hello, my name is Bogdan Panchuk. My topic is Czech Financial Transaction Report 1999. And I've prepared several dashboards which help analyze data from that report from different perspectives. First of all, I did some data cleanup. So the structure of data looks like this. Essentially, we have several data sources stored in different CSV files. They are all joined by IDs like account ID, transaction ID, and so on. And they contain different information which can be aggregated. After that, I will show that I did some data cleanup. So I've translated some fields from Czech, the values of fields from Czech language to English, also converted dates to appropriate format, a little bit enriched data, and so on. So I will start with the cross tab. In a second, yeah, with this dashboard, which gives a general overview. So the data I have, essentially the measurements are transactions amount and the derived measurements like transactions count, accounts count, clients counts, and so on. I did analysis on these measurements, and hierarchical dimensions are dates like years. They can be subdivided by quarters, month, and even days if needed, and also by essentially geographical location of the client's residence, which are subdivided by regions and also by districts in each regions. So these two dashboards show just basically the total and count for each region by date. Here from the right are two pie charts. Essentially, they show the percentage of all transactions per bank. Also, to take into account that I excluded all which has this column null, and essentially it seems like most of them has equal like contribution, but probably it's just the peculiarities of this data set. Maybe they intentionally selected approximately same amount from each bank, and also the pie chart which shows the percentage and count by the operation kind. So yeah, this is one of the translated columns um, I've created. So yeah, and this is like overview. Then if we go further, I have this dashboards which has two graphs: the average amount of transaction and the transaction count. The average amount is essentially like the average value of each transaction. So and also it's subdivided by regions, which we can drill down, for example. But also it has two another dimensions, which are average population density, which are displayed by the circle size, and the average unemployment rate in the district where, like, district of the account is associated with. So here, yeah, you can see the color range, and two graphs for account and for average transaction amount. Then we go further, we have the similar chart, but which shows the percentage of transaction amount. This is total, not average, transaction amount by age level. So this column is essentially deduced from the age ranges, because which can be calculated from the client birth date. And yeah, it's divided to 4 categories. Like youth, it's up to 25, as I remember. Senior, it's after 65, and so on. And also we can, for example, yeah, we can drill down and up based on the region, but we can also select like one region, say Praga, and see actually the scale from 0 to 100 specifically in Praga, and see how much financial activity was contributed by which of group. Yeah, okay, then we go further. We have this graph which shows the average transaction amount over each, essentially over some date. So first of all, it shows by year. The data set contains years from 93 to 98. 99 is essentially the like prediction based on the exponential average method, which uses sampling from the previous values. The older values, the less contribution it have. It tries to build some polynomial to kind of make the prediction. It doesn't work well for years, but when we drill down to quarters, we can already see that it starts guessing the trends. Like, for example, at the second quarter, they usually some kind of spike. And also if we drill down by months, say, for example, so each quarter, we see that usually at the end of the months, like, sorry, at the end of the quarter, there's always kind of uplift in the average transaction amount, probably due to taxes and yeah, commercial financial activity. And this is also kind of predicted by these like data prediction technique. Also, we can see that a senior class of citizens usually don't have such financial activity, probably because they just live on pension and they don't have a lot of commercial and business, or they don't have job. Yeah, so probably that's how this can be explained. Then we go further. We have I built 4 PKIs. So first two are transaction amount and transaction count. This is the value over the last year, so 2098. Or actually, I'm afraid, yeah, right, 2098. And then it shows the growth in percentage, or if it will be the decline, it will show minus versus the previous year. Then it shows the trend over the last year by months. So you can see from January to December. And the same for transaction count. It has two like baseline. It's not like in what my interpretation of this graph is essentially the higher commercial, like financial activity, the closer we are to inflation, and the lower it is, the closer we are to deflation. So basically, it shouldn't be too high or too low. And this baseline, I don't know the actual numbers. I'm not an economist, so I just took the standard deviation over the whole population of these years of data. And these two lines are essentially upper and lower bound of standard deviation. Then we have the PKI on the banking accounts. It has such a whole number probably because only 405, and not probably, like I checked, only 4,500 accounts were present in dataset. So yeah, the dataset quite limited, but that's what we have. And for clients, we have more clients than account because one account may have 2 clients associated with it, one owner and couple of disponents or like users. And also it's divided to this donut chart, which shows the percentage of the account by statement issuance. So either it weekly, monthly, or after each transaction. Curiously enough, it doesn't have quarterly, which I suspect the most popular nowadays. But yeah, and also by the age level. So a number of clients by the age level. So we see the most are middle age, and others are approximately similar amounts. Then also finally, I tried to do some clustering with simple k-means. I've tried different numbers of clusters, ended up with 5, but yeah, and I just presented some knowledge I already have about data, like the, again, average unemployment rate and average transaction amount over the some regions and the average salary. Like this is known in advance, and the clustering is done by average transaction amount and transaction count. Yeah, this is very abstract, so it's not like much probably we can see about it, but we definitely can see that at least it grouped some, like Bohemia is central and south to one, northwest to another. So there is some geographical probably like correlation, but k-means probably, or maybe these 2 metrics I used are not sufficient to actually build like good clusters. Yeah, that's all what I have.
Okay. I just think if you missed something you showed previously, do you have some maps or no?
No, I don't have maps. Unfortunately, I cannot tie the district name in that set with some, like maybe I could with some junk code, but I didn't have that mapping.
Okay, so you showed some correlations, and can you come back to your, yes, maybe this one, to forecast? Yeah. Forecast. What is the method for the forecast?
As I said, it calls exponential averaging or exponential sampling, like method where they take into account previous data points, but the older data points, the less weight we give to it, and then we build like polynomial with some degree which tries to approximate. And this, as far as I understand, the spread of the like predicted values.
Yes, exactly. Can you show where you have chosen exactly this method?
It's actually built into Tableau. It has like 8 different methods, and it chooses automatically one of them. But as far as I'm like from read from docs, the base one is this one.
Choose it just automatically. You haven't power to make another choice. Yes.
Yeah, like there is some customization, but the algorithm is chosen for me. So yeah.
Just a moment. I just would like to see. So you can't choose another one, yes? Okay, I see. Good. Okay, welcome.
Good evening. My name is Ruslan Teslia, and today I will be talking about the credit card customer analysis. Let me share my screen for a second. Please let me know if you see my screen.
Yes, sure.
Okay, so let's start from the description of the problem and the project and the data set they've chosen. So the project itself called Credit Card Customer Analysis, as I've already said, but the problem with it and the solution that we were trying to analyze and find is that percentage of customers are churning away their credit cards, and the managers want to know what how they can affect this and take the proactive standpoint from themselves, so they could have more customers within their banking system. So the data set itself has only 10,000 customers with the age, education, their status, their marital status, and how were they turned into the bank by themselves or by the marketing team. So here, as you can see the libraries and utilities I've chosen and used. This is for now, this is not really that important, but just for your interest. So here you can see the first thing I've wanted to show is the distribution of age and the distribution of the gender between the card holders. So as you can see, the samples don't have too many that big of a difference between male and female. So we can say it's pretty much the same. Here is divided into the types of credit cards that are here in the banking system: the platinum and the blue cards and the silver cards. So platinum is the most premium one, the blue one is the most standard one, and the silver one is the cheapest one, as I believe. So here, let me do this. Yeah. So here we can see the proportion of educational levels between the customers of the bank. Sadly, I do not have the specific information about the location or the name of the bank, but here we can see that there is a lot of people, the majority of people are graduates from the higher educational level facilities, and the other big percentage, 20% almost, is the high school graduates, as well as 15% we do not know where is coming from. So educational levels, if putting it simply, what type of you can see the people that graduated the universities are canceling more, but this is due to people with graduate level having more credit cards as well. Next up, we have the proportion of different marriage statuses. As of this data, it's pretty much not that usual for the world's status, because here everybody, a lot of people, so almost 50% are married, or 40% are single, and only 7%, which is the most uncommon thing, are only divorced, which is in the world, I believe the statistic is somewhere around like 20%, 25. So as well, you can see here a small description of the number of cancellations by marital status. So married and single take the majority of the card holders, so they're the ones who are more canceling ones, the credit cards. So next we have the income levels. So here, as we can see, the majority of people have less than $40,000 per year of annual income. It's taking the 35% of our population, and the next one is somewhere around that mark, 40, and the next up is 60 and 80. So it's pretty much divided into these small groups of people with the margin of only 20 grand. So here you can see as well that because we have the majority of people in the less than 40K, $40,000 per year annual salary, you can see that they're the ones who will mostly be canceling the credit cards. The next up, we have the different credit card categories. This is not very interesting or important. We can see here that it's important, but it's not pretty interesting, because here we can see that the blue card, which is the standard one, or you can call it the middle ground, is the most popular one. 93% of customers have it. Next up is silver, which is more basic one, and gold and platinum. So only less than 1% have a platinum card because it's pretty much expensive per month, and not everybody needs it because, as we see, not the majority of people are under the $40,000 per year of annual income. And getting to the most important topic of this whole database and this whole project is the proportion of churn and not churn customers. So here, as we can see, the existing customers and the attrited customers. So existing is the ones who were in the period of time when this database was taken, is the customers that already are in the banking system, and 16% of those, 16% is the customers that just came into the bank and were turned away. So this is the percentage of people who cancel their credit cards. Here is the next up. We have the behavior of total transactions made by customers. Here we as well divided to attrited and existing customers. As you can see, there is it's only for the last 12 months. This is the information that we have. And here you can see that the usual ones is the total transactions, and it's divided by the total transactions and by the frequency of them. So usually it's somewhere around the 80 mark with the frequency of 150. Next up, we have the total revolving credit card balance. So this one is pretty much almost, you can say almost the same value for attrited and existing customers. So it's somewhere around $1,000 usually. So next we have the data processing. So firstly, we calculated the Spearman correlation and by the Spearman correlation coefficient. And here I've shown the default calculation of it, the equation of it with the short description. So N stands for number of data points for the two variables, and the difference in another variable dg is difference in each of the n elements. So because we have only 10,000 people in the dataset, I use the data upsampling. The most common one I've seen being used for this type of cases is the SMOT, which stands for synthetic minority oversampling technique. So this is a pretty basic and pretty balanced way to upsample, to increase the number of the people you have in your data set, if you can say so. So they are not, as I highlighted in the work, they're not just copies of the existing cases. So this is why it's pretty balanced. It's not just copying and divided into two. So it takes the sample of the feature space of each target class and its nearest neighbors and generates the nearest and the new examples which combine features of the target case with the features of its neighbor. So here you can see the initial result that we have before the upsampling, and here's the result after the upsampling. After that, I've worked as the result of this work was the prediction of how much people will be turning away from their cards. And here, as you can see, a lot of people will still stay with the credit cards they have, if we take in the upsample data, of course. So here you can see that not too many people will turn away their cards and will not cancel, but as well, pretty decent percent of those will still will be canceling and going to another bank. And here, let me get it a little bit bigger. Here you can see the precision level of the prediction. Yeah, and that will be it. Maybe you have any questions, concerns?
Okay, you said that you said that you can show us like working model, yes?
Yeah, it's on my another computer. It's right now.
Impossible now, yes?
Yeah, yeah.
Okay. You have so many predictions and results. Why you have chosen exactly these models?
Model of prediction?
Yes.
Because I found it the easiest to use with this type of data, and because I was pretty much not very familiar with the upsampling method I've used. It was one of my first times of using it, so I've chosen this type of prediction because I've read into the resources that use the SMOTE, that this way is the safest to do so and the most precise one. So I was worried that the data that was created by upsampling would be somewhere incorrect, or maybe it would affect too much. Maybe because I was not doing the SMOTE not very correctly, so I was worried about it.
Yes. Okay. Thank you. Okay, you can start.
So my name is Volkovy Pavlo. 1 second.
Okay.
Okay, so my name is Volkovy Pavlo, and the topic of my report is electrocardiogram analysis. To analyze, I use the data from Lobachevsky University electrocardiography data set, and it contained 200 electrocardiograms with QRS labeling and some basic diagnoses, which were manually put there. So there were like 82 diagnoses at all, but only 200 samples. So I was restricted to choose the diagnoses that were at least somewhat common. The one group of diagnoses that was slightly more common than others was the rhythm, basic rhythm of the electrocardiogram. It contained like 7 labels, and each of them was present in the dataset with respective quantities. Okay, so which models I used to analyze and predict the respective classes? First, I tried the analytical approach that was by finding error spikes and approximating these classes based on the differences between RR intervals. So, firstly, my task was to find R spike. To find R spike, I should first remove noise. Then I should remove the low frequency component, which can move the mean of the cardiogram, if not removed. And then I should try to ignore P and T waves, which are also positive spikes, but have much smoother derivatives. Okay, so after I did all of that, the results were like the following in the confusion matrix. Then, after I found error spikes, I had to find Q and S spikes negative. For that, I just basically moved from the point of error spike until I found the local maximum of second derivative of this function. Since in some cases, like slightly here and in other cardiograms as well, these R and S spikes, they can be like not the local minimum. So it like goes through here and then like continues that way. But the difference in second derivative is quite substantial. So I use that feature to almost correctly approximate the position of these points. After that, I moved on to the boundaries of QRS, and I failed to correctly predict the boundaries of P and T, since they are a lot smoother and it's hard to find the exact boundaries. However, the spikes, P and T, the maximum values, they can be easily found by separating the RR interval, like this, in two, and finding the local maxima on each part between the last dot, which represents the boundary of QRS part, and the middle of the RR distance. Okay, so also I tried to use CNN, as you already know, and it was not really good. It slightly depended on the structure of the network, but mostly it overfitted really fast, because CNN is prone to fit on different small features such as noise, which I tried to remove, but was not fully successful with it. So also I wanted to try a recurrent neural network, but it didn't work for me, unfortunately. So the results were not as good as I wanted them to be, unfortunately. And among ideas that I didn't have time to explore was to feed the concurrent neural network the pictures like this, which can be formed by finding the R spike and basically using each string as one R interval. So basically one R spike per string, and combining them into a picture, like one row, one R interval. So that's all, I guess.
Okay, have you tried other methods which could be like unsuccessful, but nevertheless?
Basically, I used I used different convolutional models, which I even tried with minimum square error loss, just to see if it works. It works, but of course a little bit worse than with cross entropy loss. Also, I tried different approximations to improve some bad results with finding R spikes with analytical approach. So like a lot of different small fixes which helped a little bit, but not really.
Okay, but you didn't try to find like R peaks, to localize R peaks in some mode, not like just like convolutional, but to localize R peaks in beforehand. Have you tried this?
No, basically, I've tried this only in my analytical approach, which is mostly based on that. So I just removed noise, removed low frequency component, then removed detected P and T waves, which are usually have lesser first derivative.
Okay, but this data becomes the input for the next methods, or
no,
oh.
Unfortunately no. Basically, because if I would pass this data just like this, it would be, I think it would be harder for neural network to recognize tachycardia or bradycardia and such simple rhythms that are based on the difference between R spikes. Like those intervals are double R.
You mean that
I'm
they
not sure how
become
this
different?
pronounced.
You mean that they become different, or?
I mean, like in arrhythmia, in case of arrhythmia, the double R distance is different, and this is the main feature that can describe the arrhythmia, actually. So, like in fibrillation, also, it is usually like the similar distance at first, then the distance is doubled or tripled, oh no, like divided by 2 or 3, so like 3 spikes per one usual heartbeat, and then it is normal again. So basically a lot of features are based on the difference between the position of air spikes. And of course other different diagnoses, like a lot of smaller ones. I can try to get them right now, probably. Well, I'm unable to run it here. Basically, there is 82 diagnoses, which means about 75 of them I haven't explored, and they probably are much more, can be predicted much better with such pictures.
Can you say in more details about confusion matrix or for your method?
Yeah, okay. So as you can see, for the analytical approach, the confusion matrix is quite good, but it is only because I divided numbers by the amount of instances in each class. So basically here, a lot of instances are
Can
considered
you zoom in
here.
because we can see numbers?
Yeah, 1 second. I'll try.
Yes.
Is it better?
Yeah, of course.
So basically, the normal sinus rhythm is like 120, 130 samples of overall 200 samples. That's why, like, the fact that 0.1 of them are predicted as bradycardia means that like 10 to 15 samples are wrongly predicted as bradycardia. Unfortunately, because as far as I know, my algorithm detected exact BPM, so basically exact heart rhythm, and in most cases. And some of those cases where I don't know why it is labeled like normal rhythm, not a bradycardia, because it was like below 60 beats per minute. But in some cases, if I raise the limit over 60 beats per minute, was predicted as bradycardia, or below 60 as normal rhythm. So these two classes, they're like really overlap, unlike every other class. So I try to predict arrhythmia quite successfully, I think. And these 3 classes I basically didn't predict at all. I just took the cases where I could not find R spikes, or the difference between R double R intervals was too big, like 2 or 3 times bigger than usual. I just put it in this class. So basically I was focused on these 4 classes. And this class has like 1 or 2 samples in it. And since it is irregular sinus rhythm, it is technically an arrhythmia.
So by rows we see the real situation, and by columns
the predicted.
The prediction. Okay, I see. Thank you. Добре, отже, слухаємо.
Доброго дня, мене звати на початку Олексій. Показую лабораторну роботу з датасетом з транзакцій в банкоматі в Данії за 2017 рік. 2,5 мільйони транзакцій. Тут включені тільки зняття готівки в цих транзакціях. Також у кожної транзакції є ще дані про поточну погоду, проте це як бонус. Ось структура даних цього датасету. Тобто там один був CSV файл, в якому наступні стовпчики. Тобто дата, рік, місяць, день, день тижня, година, потім інформація про банкомат, його ID, производитель, manufacturer, локація і адреса, потім валюта, в яким відбувалася транзакція, тип карти. Тут в цьому датасеті тип сервісу тільки є зняття готівки, тобто нема депозитів. Потім, якщо помилка в процесі, то повідомлення про помилку, код помилки, і також інформація про погоду, координати, місто, температура, тиск, вологість, швидкість вітру, напрямок, опади, хмарність і детальний опис. Тобто взяв я цей датасет і його імпортував в Power BI. І потім розбив на з однієї таблиці зробив кілька таблиць по вимірам одномірно. Тобто окремо виокремив інформацію про банкомати, їх всього 113, також про локацію погоди і про опади. Далі зробив pivot tables. Тобто тут я згрупував в першій таблиці по годинам дня кількість транзакцій і в різних валютах. Ну, як бачимо, що слідувало сподівати, що протягом дня більше транзакцій, і ввечері, вночі, зранку менше. Тут по датам кількість транзакцій, по кварталам, по місяцям, також можна окремо по дням подивитися. І ось всього майже 2,5 мільйони транзакцій. По дням тижня інформація. Там далі буде графік, на якому по дням тижня. Так що тут потім по типам картки. Якщо написано on us, то це картка видана банком, який збирав, власне, ці дані. Тобто клієнт цього банку. І також включив інформацію про погоду і вологість, і кількість транзакцій. Потім графіки. Тут pie-chart з валютою. Як бачимо, звичайно, більшість майже більше, ніж 98% в датських кронах в національній валюті і майже 2% в євро, тому що в Європі країна. Ось по дням тижня, тут один це понеділок, тут понеділок, вівторок, середа, четвер, п'ятниця, субота, неділя. І бачимо, що в п'ятницю більше всього знімають. Це, скоріш за все, зумовлено тим, що в кінці робочого тижня люди йдуть відпочивати і тому знімають готівку. Тут також по містам відсортовано по кількості транзакцій всі міста. Потім по місяцям, як бачимо, весною влітку більше, зимою зменшується. Тут також включив про производителей банкоматів, їх всього 2. Ну, тут це скільки транзакцій, в якому, і тут скільки банкоматів. Також по Donut Chart по типу картки. Бачимо більшість, ну, майже половина, не більшість, а майже половина по картках цього банку. І тут по дням кожного дня скільки транзакцій за цей день, ну, протягом всього року. Як бачимо, тут після Різдва просіло. І також видно, що в кінці кожного місяця у нас піки. Це, скоріш за все, зумовлено тим, що отримують зарплату в кінці місяця і знімають. Також у нас є інформація про помилки в транзакціях, тому можемо подивитися на статистику, скільки відсоток помилок, і, ну, відповідно теж по дням, по місяцям. Як бачимо, усього 0,32% помилок. Не впевнений, чи багато це, чи мало. Проте, якщо подивитися на тренд, то бачимо, що ну, і тут видно, що під кінець року зросла кількість помилок, що не є хорошим. І тут спарклайни. Ну, тут просто по місяцям кількість транзакцій і ну, по дням тут на цих спарклайнах. Ну і от бачимо, що майже в усі місяці в останній день скачок. Ну,
В останній день тижня, так?
Ну, в останній день місяця. Ну, і тут, ну, це, скоріш всього, п'ятниці, як ми бачили, що в п'ятницю у нас більше транзакцій, і ось ці невеликі піки – це в п'ятницю, а великий – в останній день місяця. Ну,
По графіках, звітах, дешбордах ще є?
Ні, все.
Угу. І прогнозні якісь показники, прогнозна частина, третя задача?
Не робив.
Добре, зрозуміло. Тобто поки що все.
Так.
Добре, дякую. Окей, so let's go.
Hello, my name is Mikita. I am a student of the second course of the AI program. And also I'm running a project called Recurrent. We are doing shelf analysis for retailers and suppliers. Currently, we are taking part in the Rich Incubator Challenge by the EU Horizon 2020 program. One of the challenges they provide is the evaluation of customer data in emergency situations. So I've tried to analyze the data provided by the challenge. Let me show you the structure of the data. They have provided the customer DNA and customer transaction data, where customer DNA means value segmentation, lifestyle type, age, and the presence or absence of children. And they have per transaction data, including the date time, the location with encoded brand and store IDs, and SKU and gross sales. So what tasks have we aimed to tackle in this challenge? We try to extract the following insights. influence of demographics on consumer behavior, and also correlation of stores, and evaluate sales dynamics with performance of online sales and customer retention rates. The dataset had the following metrics: number of visits, sales, receipt size, number of items sold. And we have included the following values as the dimensions: store brand location and type, customer age, behavior, lifestyle and family, and products. In addition to analyzing and visualizing the data in a dashboard, we have made predictive models to evaluate potential customer lifetime value, mean transaction size, and to evaluate the transaction size of each transaction. So let us show the visualization. So we have shown the total sales during the analyzed period. The provided sample data included times from March to June 2019. We can see the total sales, total value. We have evaluated average customer lifetime value and their lifetime. So we see that the customer most often has long-term customers and doesn't have high rate of drops. The average receipt size, which is medium, approximately 25 euros, and the total number of customers. As we can see, each customer approximately made an average 12 visits during the period. The charts definitely depict the seasonality, so like more visits on weekends, etc. Well, typical retail stuff. So let us take a look. The provided dataset had 4 types of stores, 2 of them fully offline, 1 of them mixed online and offline, and the last one fully online. As this is the 2019 data in the pre-COVID era, we can see that online sales are really weak. They are not really useful and don't make any meaningful difference. As we can see, the 3 physical stores have rather large amounts of sales with over 200,000 store visits per month. So, and as we can see, there are approximately like 10% of repeat customers based on the data. And the customer count chart correlates with the revenue count, so there are no significant outliers in regards to transaction value. So here is another visualization of store sales breakdown. We can see that the store numbered 303 is, yes, 303 is the most popular here, but the 143 store has a larger average receipt size and offers higher value per customer, as we can see. But their seasonality charts and time-based trends are rather similar. Here we can take a look at the customer demographics. As we can see, the customers are mostly middle-aged to old, as 6 denotes the oldest auditorium and 1 denotes children. They have different behaviors. So some of them are frequent buyers, some of them are occasional buyers. This segment denotes the most occasional buyers who occasionally come to the store and buy a few products. And with different lifestyle segments, it refers to urban, rural settings, etc. Approximately a quarter of the customers has any children. And if we look at the store visits per demographics, as we can see, the oldest population visits the stores the least, and middle-aged customers visited the most. And we can see similar trends with lifestyle segments and values. Basically, revenue mostly correlates with store visits, so we didn't derive any insight about dependence of demographics on average receipt size. but they have some differences. So let's take a look at the models. So we have built a transaction value model which tries to estimate net sales based on full transaction data, taking into account the demographic data and store location and day of week and time of hour. We have trained a boosted tree regression model with 6 iterations with all performing L2 regularization. Training has made some progress, but we have not succeeded in having a high accuracy. Our mean squared error is approximately 28.5. In addition, we try to predict customer lifetime value with the same kind of a true regressor. The model continued training, but similarly, either we have misconfigured the training procedure with BigQuery or finding correlation between data and the final label value is really hard. In addition, we have tried estimating mean receipt, which has received high accuracy with a linear model. So while our experiments in evaluating machine learning algorithms on the data were not successful, but it was expected, as this is actually a data challenge. So this is actually, well, a data science challenge, so it's not really easy to find meaningful baseline models which fit on the data. Something like that. I'm done.
So what are your main results, main resume of this challenge?
So the main resume on this challenge is that we definitely need to take into account external data sources in addition to customer trends and store data to correctly estimate the sales values and dynamics. For example, news sources which correlate with events, and also further historical data based on more diverse markets. Yeah, so basically these are the key takeaways, that we need to take diverse data sources to accurately predict demand. As actually, well, this was stated by the organizers of the challenge as one of the main goals was to find nice data sources. And another insight we've gathered is that before COVID, online sales of retailers were really insignificant, so it really has provided a boost. Unfortunately, they didn't provide us the data for 2020 yet, but it will be interesting to take a look at it when it arrives.
Mm-hmm. And does this project have some interaction or direct intersection with your project, with your study?
Yes, while our main service is shelf monitoring with cameras, in addition, we try to evaluate the possible future demand. So we'll actually provide tips to our customers as to future stocking levels. We will combine historic sales trends, market research, and direct shelf data and customer behavior to forecast which items will sell when, how many, etc. To make our customer stores even more efficient, helping them extract more revenue.
Okay, thank you.
Thank you.